Good morning, all of you. Last class we discussed terminating decimals. That is, when we divide a rational number by another one, we will get, when we convert that into decimals, we will get a definite number after the decimal point. Now, today we want to discuss another type of decimals, non-terminating decimals. Non-terminating decimals, again we can divide it into two: non-terminating recurring decimals and non-terminating non-recurring decimals. Okay, non-terminating recurring decimals, that is when we divide a number by another in the decimal numbers, if the decimal numbers continue and do not come to an end, that will not be its decimals will not be end to one number. So such decimals are called non-terminating recurring decimals. In that case, we will never get the remainder as 0. Okay, we will never get it 0. But in the case of terminating, yesterday we discussed terminating. In that case, always we will get the remainder 0. Now here you look one example, 1 by 3. When we divide 1 by 3, okay, through its normal division, we can do it's 1 by 3, 0. So subtracting, we will get 1, then bring 1 0, then put the decimal points, then 3, 10 divided by 3 we will get 3, 3 into 3, 9, 10 minus 9, 1, then 0, again 10 by 3 we will get 3, so 9. So this will be repeating, this case will be repeating, we will never get a remainder as 0. So this such type of decimals are called non-terminating recurring decimals. Recurring means repeating. So in this case, which digit is repeating? 3 is repeating. So this we can represent as this type 0.3. Here 3 is repeating. So we can put a bar on above this 3. So what is this mean? Its mean will be, this will be equal to 0.333. This digit 3 is repeating. So this is an example for non-terminating recurring decimals. Another example, when we divide 5 by 6, is it? And 5 by 6 when we take, look that example 5 by 6, here we will get, first we will get 0, 0, 5 minus 0, 5, then 50, then put a decimal point. In decimal point, here we will get 8, 8 into 6, 48. Now 2 will get the remainder. Now the big number become 20. In 20, 3, 6 are there. 3 into 6, 18. Now it will be repeating. That is, this number, digit 3 is repeating always. So in this case also, one digit 3 is repeating here. So that also include in this case non-terminating recurring decimals. Here before that 3, one digit 8 came. That's no problem. Anyway, one digit 3 is repeating. So this we can represent as 0.83 and then put the bar above this 3. So what does this mean? In this case, the digit 3 is repeating. So this will be 0.8333 at this case. Okay, so these cases are called, that is, if any decimal point is repeating after that decimal point, such decimals are called non-terminating recurring decimals. And another case is non-terminating non-recurring decimals. That this type of decimal, any example we can check. One decimal number I am writing 0.718356 this type. Here also there will not be any end. So any number not any digit is repeating also, not repeating also. Okay, such cases also there. First decimals also there. That is, here any digit is repeating after the decimal point? No. And these cases, in this such type of decimals are called non-terminating non-recurring decimals. Non-terminating non-recurring decimals. That is, in this case, these decimals we cannot convert into a rational form. We cannot write that in a rational form, a by b or p by q. It is not possible. But in this case, it is possible to write as in the rational form 0.83 bar. This how we can write as the rational form, because 5 by 6 for when we convert 5 by 6 into decimal form, we got this. So this we can represent as a rational number. But in this case, it is not possible to convert into a rational form, a by b form. Such decimals are called non-terminating, non-recurring decimals. Okay. So another these such decimals are called one name that is irrational numbers. Such numbers are called this. We can write as, because it is not it cannot be expressed in the form a by b. So this type of decimals are called irrational numbers. Irrational numbers. Okay, so in this type of decimals you will study in higher classes. So irrational number example, did you see this type of numbers? Root 2, root 3, this type of numbers. Its value also given. In the textbook it is given root 2 is 1 point, look, root 2 is given 1.4142135 Okay, in this any digit is repeating? No, it is a continuous repeating need. It is not repeated. 4 after 4, next 1, next 4, then 2, then 1, 3, 5, 2. Here not any digit is not repeating continuously. Such numbers are called irrational numbers. Examples are root 2, and for root 3 also given one value in the textbook 1.732050. You can see in your textbook. So that is the difference of non-terminating recurring decimals and non-terminating non-recurring decimals. Now we can take in our textbook. All of you take your textbook, page number 62. We can take one question. Which of the given decimals can be expressed as a rational number? Why? The third question, you can look at question A, 7.305. 7.305. Can we express that in 7.305? One number is given. Can we convert that into, can we express this decimal as a rational or not? Yes, it is possible, because here definite number decimals are given after the decimal point. So it will be possible. Next, 0.222, this type. Can we? Because it also we can represent in the rational form. It including which category? Non-terminating recurring decimals, because one digit 2 is repeating. So this we can convert into rational form. Another one is given 36.123721817 and continues this. Can we express this in a rational form? No, because here after the decimal point any digit is not repeating continuously. Such numbers, this we cannot write in the form of rational number. So these are the main difference of non-terminating recurring decimals and non-terminating non-recurring decimals. And we can do that. You can do two homeworks. Exercise 4E 2 and 3. Okay. Thank you.